continue our chapter 3. Chapter 3.1, Extrema on the interval. So let's look at definition and theorem first. This is an important definition. So definition of critical number. Let f be defined at c. If the derivative of f of c equal to 0, or if f is not differentiable at c, then c is a critical number of f. Now, the theorem 3.2 tell you how to find relative extrema occurred only at critical number. So if f has a relative minimum or a relative maximum at x equal to c, then c is called a critical number. Let's look at our example here. They want you to locate the absolute extrema of a function. So I have a function here, f of x is equal to x to the cube minus 12x, and it's on the interval 0, 4, including 0 and 4. So they want you to find extrema. So we're going to use the theorem and the definition here. So to find the extrema, we need to find the critical number. So what we need to do is we're going to take derivative of a function, set it equal to 0, and solve for c. c that make the derivative equal to 0. So I'm going to take derivative of this. Then I would have 3x squared minus 12. Alright, from the definition, it tells you to take derivative. After you take derivative, you set it equal to 0. So I'm going to set it equal to 0. Then you're going to solve for c. c is a critical number. Alright, we're going to solve for c. c is the critical number. In our case here is our x. So I'm going to factor out the 3. I left with x squared minus 4 equal to 0. I'm going to factor some more. So this is 3. X plus 2, x minus 2 equal to 0. You have 3 terms multiply each other. 3, x plus 2 and x minus 2. One of them have to be 0 or more than 1. 3 will never equal to 0. So if x plus 2 equal to 0, then x is equal to negative 2. Alright? If x minus 2 equal to 0, then x equal to 2. So this is your critical number. However, we have an interval here. Our interval is 0 to 4, including 0 and including 4. So this is our interval. So we're not going to use this. So our x is equal to 2, because 2 is between 0 and 4. Now we're going to check the relative max and relative mean. So if f have a relative max or relative mean or relative max at x equal to c, remember my c is 2, c is called critical number. So I'm going to test at the endpoint 0, 4, and 2. Alright, so the endpoint x equal to 0 is 1. You're going to substitute in the original function. So f of 0, you're going to have 0. So what it means is if x equal to 0, y equal to 0 from this function, the graph. Alright, now I have a critical number which is x equal to 2. We're not going to use negative 2 because negative 2 is not in there. So critical number x equal to 2. Again, I'm going to substitute in here. Alright, so I have f of 2. So I'm going to have 2 to the cube minus 12 times 2. 2 to the cube is 8 minus 24. So that's minus 16. Alright, now I have to check my endpoint here as well. 4. So my endpoint, x equal to 4. Substitute it in here. So I have f of 4 would be 4 to the cube minus 12 times 4, which is 16. Alright, so when x is 0, y is 0. When x is 2, y is 16. When x is 4, y is 16. So this is the relative max and this is the relative mean. Because this is the highest point in that interval. Now if your critical number is more than 1, you have to check all the critical number. Alright, we finished 3.1. I'll see you next time.